Hello. Good afternoon, ladies and gentlemen, and thank you and welcome for coming to this session on understanding and reducing. Sorry. Yeah. Thank you for coming for this afternoon session on understanding and reducing harmful emissions for human health.
Mr. Jamalis, I don't think it works. Maybe you
can take it closer. You're a bit hard.
Like eating it. Okay. Thank you for coming to this last session. And we're going to present 4 projects in the area of understanding and reducing harmful emissions for human health. This is quite an important issue for EU, and it's actually reflected to the communication and the EU action plan that was issued almost a year ago, titled Towards Zero Pollution for Air, Water and Soil. In this work plan, which in combination, let's say, with the goals set in the Green Deal, one of the targets for 2030 is to reduce the health impacts of air pollution by at least 55%, and as well by 30% share of people chronically disturbed by transport noise. And the project we're going to present here touches on both these issues, the air emissions and as well the transport noise. Actually, in 2022, the Commission will propose that the EU's air quality standards to be aligned more closely with the WHO recommendations, and that the provisions for monitoring the air quality should be made in order to help the local authorities to reduce those both air and noise emissions. And actually, the need to consider to limit further the emission of PM 2.5 and RTO particles from all types of combustion engines, and as well as from brakes. So the zero emission vehicles are not excluded from actually these actions. Will be considered and will be published within the year. So without further ado, I will start. We can start with the first project. The procedure will be that all projects will present all 4 projects, and then at the end there will be a Q&A session for all questions that you have regarding what was being presented. So the first project is, I'm glad to welcome Professor Topi Ranko, and he's going to present Project Tubes on transport-derived ultrafine and their brain effects, quite an important issue that highlights the harmful impact of transport emissions to human health. The floor is yours. Thank you.
Thank you, Chairman, and thank you. Thanks for this opportunity to present our project, which is a tube project or transport-derived ultrafines and the brain effects. And this project is a 4-year project, so that we are now actively making research in different work packages, and we are going through the data analysis phase and publication phase. So I may not present very much results in this presentation, but the basic idea of the project and then some preliminary or first results from one work package. So I'm coordinating one work package 1 in this project, and the whole project is coordinated by Professor Pasi Alava. So I'm behalf of him here today. So Tube project aims to discover harmful components of air pollution and to identify biomarkers to early detection of brain disease related to air pollution. So there have been scientific articles, observations that, for example, living near traffic routes or roads can increase the cases of Alzheimer's disease. And then there are some indications that those increased number of cases are because of particulate pollutants. So in this two project, we try to understand how those particles of ambient air can affect human brains and also on lungs. And then we try to combine that kind of scientific knowledge with knowledge on the emissions, so that we try to understand that how we can change vehicle technology so that those possible effects on Alzheimer's disease can be decreased. So in this project, the main focus is on ultrafine particles from road traffic. And ultrafine particles means particles smaller than 100 nanometers. And then we have included also disease mechanism research and then translocation research and clearance research in this project regarding the pollutants affecting brain and going to brain and going out of brains. We conduct respiratory toxicology and genotoxicity experiments with online exposure system, so, typically so-called air liquid interface systems. Then we study these things related to the engine exhaust from cars, trucks, buses, marine engines, and then also related to the effects of those traffic modes on ambient aerosols in normal city environments. Then we try to combine toxicological research in cells, mice, and human to provide better tools. Then we use also epidemiological data, both from Sweden and China, and then we have one intervention study in Chile related to the electric buses and their effects on air pollution. We have 17 partners in the project. The total budget of the project it is more than 5 million euros, but the number of partners is also very large. We have expertises from engine-related research, aerosol emission research, toxicology, epidemiology, and then instrument development. And also the development of cell models is included into the consortium. We have several work packages, even 10 work packages, but those work packages from 1 to 6 are the most important in the actual work. In work package 1, we study the emissions from different sources, the particles in ambient air in different environments, and then we collect particle samples so that they can be used, those particles can be used in toxicological and other health-related studies in other work packages. So that work package 2 is focusing on lung health, and work package 3 on brain health. And then work package 4 aims to understand how those pollutants or harmful compounds in brains because of pollutants can be removed, or how they go out from brain. And then there is one work package where we study those things related to the human volunteers and epidemiological data. And work package 6 is aiming to build some kind of summary of all of this knowledge produced by other work packages, so that we could make at the end of the project recommendations to politicians, for example, how to change, for example, regulations affecting vehicle technologies. And we try to describe how that kind of possible changes affect the risk for Alzheimer's disease and other brain diseases. Then I have one slide for each work package. Work package 1 is a very practical work package. We have conducted several measurement campaigns there. We are now conducting measurements in Prague, where we characterize the composition and size distribution of the traffic-related pollutants, particulate pollutants in real environments. And that's the last campaign in that work package. Then we have provided particle samples to other work packages, and importantly we have developed also the technologies which can be used in sampling of those very small particles. Then in work package 2, the focus has been in developing the methods in inhalation toxicology experiments using especially air-liquid interface systems. There are both in vitro and in vivo studies in that work package, and this is using the particulate samples from work package 1. So, for example, particles from gasoline engine exhaust are tested in this work package, as well as in this third work package, which is focusing on the brain cells and how the particles can affect the functions of those cells. Then work package 4 is doing research on different mechanisms, how those pollutants can go out from brain. There are 3 different possible mechanisms, and this work package may tell something about the significance of those possible mechanisms. And then work package 1 is using data from epidemiological studies, and it makes experiments with human volunteers. And then work package 6 is for the summary work. Then some examples of first publications, so that we have published the article describing the true project in general, so that everyone can find our research plan practically and main ideas of the project. Then we have published one article where we compare the air quality in respect of the human lung deposition of particles, and then so that we have measured things in clean city and then very polluted city. Those cities are Helsinki and New Delhi. And then in one article we have studied how the soot emission can affect the so-called LDSA, or lung deposit surface area of particles. And here you can see some examples from those articles. Here you see particle size number size distributions from Delhi and Helsinki, so that this red curve is from Delhi. These are LDSA size distributions, and these are particulate mass size distributions. And there are very significant differences, and especially in these lung deposit surface area size distributions. And this was very interesting finding and new practically. And then in this other article we studied how different traffic modes affects the lung deposit surface area size distributions of particles. And there are differences, not major but significant. For example, in harbor areas there are larger contributions from larger particles to lung deposition. So there can be also differences in health effects of particles depending on the source of those particles, and it's very important to note. These measurements these data analysts take into account also the deposition function of human brains. So these are examples, very first examples of our results. We are continuing the project and we will publish other articles and reports. Here is a summary, very short summary of our project. So it is very multidisciplinary project where we can combine research on engine emissions, engine technologies, fuel technologies, ambient air quality, and health impact studies, including both the toxicological and epidemiological studies. And then this project is based on joint experiments with experts from different institutes, and it has been a very efficient way to make new knowledge, to produce new knowledge. So thank you for the attention.
Thank you very much for your very thorough presentation. And now we pass on to the second project, this project Motales. Mr. Andrew Winder will present it, and this project's aim is to modify drivers' behavior to adapt for lower emissions.
Hello. Thank you very much. Good afternoon. So this is a slightly different take. We're not talking about the health risks like the Tube project. Maybe the main thing we have in common with yours is that we have a lot of participation from Finland, which is good. So this is about modifying drivers' behavior to adapt for lower emissions, not just driver behavior, but also maintenance behavior and also legal aspects. So not just while you're driving the car, but before and after as well. So this is an overview of the vision of Motales. It's to reduce air pollution from all types of road vehicles, so mainly cars, but also heavier vehicles as well, by encouraging low-emission driving behaviour and better maintenance choice. We're looking especially at the older vehicles because there is more scope for improvement. The newer, cleaner vehicles already, I mean, there is scope for improvement, but it's harder. We are recognising that even if electromobility is the future, it's not going to happen tomorrow. The average age of vehicles in Europe is I think around 11, 12 years for cars, so that's not going to change significantly straight away. So we have to look at ways of reducing emissions from older cars, especially in urban areas where they cause health problems. And we're looking at the covariability. Don't really like that word, but it's between the user behavior and the vehicle emissions from not just the powertrain, but also the brakes and tires. And this is how it's different from eco-driving projects that have happened before. So I give credit to one previous project that I worked on with some of the partners in here, like University of Leeds, was called Eco Driver, ended in 2016. That was a very successful project on eco-driving, on reducing CO2, and this is taking a step further and looking at other emissions apart from CO2, so particularly NOx and particle matter. You see a little diagram here. If you go to our website, you'll see it bigger. So the main 4 themes are the driver, retrofits, onboard diagnostics, and periodic inspections. This is the overview of the project. So we have 16 full partners funded by the EU, plus 2, it's an INCO, International Cooperation Project, so we have 2 partners in China as well, Southeast University, and Sample Technology, which is a SME technology firm in Nanjing, so that will be one of our pilot sites. We have notably, because we're talking about tyres and brakes as well as powertrain. We have on the industry line, second to bottom, we have Brembo, which is a major brake manufacturer in Italy. And then on the tyre side, we have Bridgestone and Michelin, which I'm sure you all know. And some of our other partners, for example, user groups like RAC. And I'm pleased to see that one of our partners, LIST University, Luxembourg Institute of Science and Technology, is represented here, and our project officer is represented here, so welcome and thank you. And we're in the final of 3-year project, or maybe 3.5 years, because we've all had a little bit of delay because of something that has happened in the last 2 years. The objectives are really to understand the nature of driving behaviour, and also how it varies, not just between drivers, but even for the same driver in different circumstances with different types of vehicles. Also, we're developing a smartphone app, which is to give real-time driver assistance. This is currently is further being developed. The basic version is available and it's undergoing testing at the moment. There have been eco-driving apps and onboard systems before. This is taking it a little step further to take into account the brakes and the tyres emissions, for example. We're trying to make it easy to use and easy to download. Then on the training side, we developed some training courses. These have just been done, and again, it was going to be physical courses, but because of COVID, we've developed a series of videos which we are testing or about to test on people in 8 pilot sites. Once that has been done, then I expect that they will be released more publicly. And then a separate technical part of the project is to look at the effectiveness of onboard diagnostics, the OBD, and technical inspections. So that's the MOT or control technique or whatever you have in your country, where they are maybe stronger and weaker in different countries of Europe because they're not fully standardized everywhere. And also the legal situation of tampering. So illegal tampering, and we've had a study on the legal situation in different European countries, and again the results are quite diverse. Let's say some places it's not really treated seriously, in other places it is. So we are working on best practice for national administrations as regards tampering and OBD and inspections. And then the last part, which is a more practical part, we have a partner in Finland. It's this one, Provencia here. They are specialised on retrofits. So they've retrofitted a lot of buses and also some trucks. So diesel retrofits, and part of the project is also assessing those, the ones that have been done, but also seeing how they can be applied to smaller vehicles like cars or vans. So this is the first part of the key results. So on the left, we have powertrain or exhaust emissions. What happened here, we had some tests. You see the far top left, there's a vehicle with a contraption on the back of it, and that's a PEMS test. It's a portable emissions modelling system. And our partner near Helsinki, VTT, did an experiment with one of these on the back of different cars, where 15 people drove 6 different cars around a circuit around Espoo and Helsinki, about 20, 25, 28 kilometers. They drove each of 6 cars twice, 4 petrol cars, 2 diesel cars, a mixture of genders, age groups, driving experiences, and a route which has a mixture of urban, rural, motorway, traffic lights, roundabouts, everything you can think of, speed bumps, bends. And this was to look at the variability both between vehicles, between drivers in the same vehicle, and on different parts of the road section, and also between age groups, gender, and so on. This was really to bring in the information needed to develop the app and the guidelines. In the middle, we have brake emissions, and our partner in Italy, Brembo Brakes, set up a dyno bench where it was an in-lab test using braking on a Ford Focus car, and different size of particle particle matter was measured, both using the standard test procedure, the WLTP reference cycle, and also a modified reference cycle taking into account the eco or low emission driving advice from Motales. And between these two cycles or driving styles in the lab, they've reduced PM10, PM2.5, PM10 and so on between 48 and 58%. So we can see there is a lot of scope for improvement. I don't think we pretend that everyone who follows our advice is going to reduce their emissions by 50%, but if that is possible in a lab, then I think there is still some good scope for improvement in the real world. And then lastly, on the right, you have the tyre wear emissions. So our tyre partners, Michelin and Bridgestone, did a series of tests using real-world emissions against based on historical data for 3 years on 81 taxis in 3 cities, Rome, Milan and Athens, and with a OBD dongle to measure the driving parameters and the tyre wear on the front and rear left and right tyres. And there were some quite interesting differences in terms of which tyres get worn the most. It tended to be the front right one in countries where you drive on the right at least. Then from that, from all these tests on the previous slide, we developed a range of ranking of factors, so that the things that cause the most pollution. So on the left, you have the driving behavior KPIs for exhaust emissions, and the number 1 ranking was the aggressiveness of driving, which is measured by the % of time spent in acceleration. And then there's the average acceleration and speed and so on. And then on the top right, you have the top ranking for brakes, so the deceleration rate, the average deceleration rate of braking, braking distance and time, and so on. And then on the bottom right, you have tyres, which is the tyre wear generated by these different manoeuvres. So, for example, the top ones are deceleration rate while braking towards the right, acceleration rate while accelerating on the right, initial speed while right braking, and so on. And then you have left braking and straight braking as well. So these are coming from all these previous tests, and then we have a kind of behavior matrix. So the ones at the top of each table are the ones we need to maybe reduce or treat the most, the biggest wins, if you like. Then the separate part of the project really was on retrofits, and there was a theoretical part, a study on the potential of NOx retrofit technologies for cars, focusing on SCR, selective catalytic reduction, and ACCT, ammonia creation and conversion technology, on the efficiency and the response and the complexity of these. And this is all just been provided in a deliverable now. And then our partner in Finland, or 2 partners in Finland, Provencia and VTT, did some real-world retrofit tests on heavy and light vehicles, including fitting the Provencia NOx buster to a light van, and previously it's only been fitted to heavy trucks and buses. So this was maybe the smallest vehicle that this has been tested on, so this is maybe a bit of a breakthrough. It did perform very well. The main reason that these things can't be fitted easily to smaller vehicles is simply their size. If you've got something that big, you can't get it in a car. So it's really just a practical thing. Then we have the part that our partner List in Luxembourg is leading, and this is the low emission driving app. So a draft version of this is already online, but it's for private access only because we're in the process of testing it. But the intention is to make it more public at the end of the project, and this will give active recommendations while the user is driving, but very simplified ones, so as not to distract the driver. They would be on a standard smartphone that would be on a holder, so just like the kind you might use for navigation. And then passive recommendations, we call them, which are after a trip. It can give you a trip report and advice for next time and what maybe your score and if you've improved or not. And these are being tested at the moment with an OBD dongle that looks like this, which is linked to the smartphone app and transmits data directly to the server run by List so that we can analyze it. And of course, it's all the volunteers are anonymized, so we just get volunteer ABC123 on our database. Of course, we're not interested in people's personal identity or behavior, but just we know that a person who is maybe, say, female, age 30 to 50, this kind of thing, so we can see by gender, age, and driving experience, and car type and car age, the kind of behavior and usage of the app. So this is being trialled. Trials are starting in these countries in red. Well, in cities in countries being in red, so in Barcelona, Leeds, Helsinki, Thessaloniki, and so on, as well as later on a city in China, Nanjing. We have a baseline ongoing at the moment, and then we will subject, that's not the right word, we will offer to our volunteers a training video where different advice is given, and then they will re-download the full version of the app which gives advice, and we can see how the driving style develops from the data from the OBD. There's an ongoing awareness campaign as well, supported by our partners, FIA and various automobile clubs in Europe. So overall, we are looking to reduce, maybe it's a big ask, 25 to 30% in pollutant emissions only from the tampered or poorly maintained vehicles. So one of the aims is to root out the vehicles that are really tampered or poorly maintained that are causing the most pollution. To advance knowledge of retrofits, and they are reducing 50 or 60% in particle matter, these retrofit NOx buster technology, and also 20% reduction in non-engine particle matter, so this is brakes and tyres. Those are our key targets. I think we're getting close to them. And then on the driver side, we say, following training and use of an app, we think that 5 to 10% reductions of emissions are possible. Previous projects like EcoDriver that I mentioned bore this out. It was maybe between about 3 and 12%, depending on the driver, the type of vehicle, and so on. The key thing is room for improvement. Obviously, the ones who are doing less well but willing to improve, you've got a bigger scope for improvement. And then lastly, providing technical evidence, and we're providing advice and recommendations on OBD and retrofit technologies, and also on reducing tampering. I think this is something that is more dealt with by the DS project, which will be presented next. So they are going into it on a maybe more deeply than we have in this project. And then the next steps, well, we're in our final year, finalization of the recommendations in the app, which is based on the things I showed before, like scoring matrices, the trials ongoing in 8 countries, and then which user groups have the most impact, where are the big wins. And then also we'll do a scaling up exercise and impact assessment at the end of this year, as well as potential reductions through OBD optimization. So that is the end. There's all our website, social media. So please don't hesitate to get in touch. And thank you very much.
Thank you very much for another very detailed and very interesting presentation. And we move now to the next project. It's a project DIAS that has similarities with the project just presented. It's on smart adaptive remote diagnostic anti-tampering systems. And I give the floor to Dimitrios Conceps from Aristotle University of Thessaloniki. Thank you.
Thank you very much. Thanks a lot. Hello, good afternoon also from my side. My name is Dimitrios Conceps. I'm from the Aristotle University of Thessaloniki, and the target of my presentation is to give you an idea about this DIAS project, which stands for Diagnostic Anti-Tampering Systems, which we hope to be smart, adaptive, and remote. Let me start with some introduction and about the consortium mainly. We are in total 11 partners with different competencies and expertise. We have testing, OBD, OBM, diagnostics, IoT, security, and policy legislations. So we tried and we hope we cover all necessary expertise in this area. There is an international cooperation from in total 8 countries, and we are part of the Horizon 2020 for smart, green and integrated transport sector. The budget was close to 5 million euros, and the duration was and is 36 months. We are close to the end of this project. August will be the final month of our project. If we say a few things about the problem, we use here the example of NOx emissions. We know that the average Euro 6 emissions from the fleet average are more or less 20 to 30 milligrams per kilometer, and this is mainly due to the advanced exhaust treatment systems, or the environmental protection systems, as we call it in this project. The problem is that the tampered vehicles can really increase the emissions more than 10 times compared to what we see from these average values. And if we use an example of sensitivity analysis, we are currently performing actually 1% of increase of tampered vehicles can lead to something like 60% increase fleet emissions in 2040. And overall, I want to highlight another number here, that up to 10% of Euro 5 and Euro 6 vehicles in the EU are estimated to be tampered with their environmental protection system. And of course, we want to stop this. In order to do so, we are working in 3 directions mainly: detection, prevention, and reporting. As regards the detection, the plan is to use advanced OBD and OBM. In terms of prevention, the target is to harden in-vehicle communication and component security. And in terms of reporting, we want to report both tampering values and tampering-related data to appropriate authorities. Overall, we can say that we want to make tampering economically unattractive and, of course, reduce emissions. Our methodology is divided in 4 main objectives: the market analysis, the detection methods and countermeasure the development of these methods, the demonstration of the success of our developed solutions, and finally, some guidelines and recommendations. I will spend the next slides for these objectives, starting from the first objective, the market analysis. In terms of the affected systems, we have identified mainly here issues with, especially with diesel vehicles. We started from heavy duty, but the similar issues are also on the light duty vehicles, and we have categorized them according to the environmental protection system that they are dealing with. So we have the ACR, DPF, EGR, and 3-way tampering. One of the main motivations for the tamperers or the owners that are tampering with the environmental protection systems is to reduce the cost of consumables, for example, the AdBlue in case of the ACR, or to reduce the cost of replacing a malfunctioning component. For example, the ACR catalyst or the filter, the diesel particulate filter in the second case. For the EGR and the 3-way tampering, we see that it's not the case anymore. There are some effective solutions already, and it was quite easy to solve these issues because also the motivation was not really high at the end to tamper with these systems. We also try to categorize the tampering methods. We start from the first one, which is the ECU reprogramming. We see it as the major issue here. and this includes the manipulation of the calibration values in the ECU. It's a relatively complex method with relatively high cost compared to emulators mainly here, and it is used by experienced tamperers. The second category is the emulators, which are some devices which can provide manipulated signals and DTC clearance command to the ECU. It's significantly lower the cost in this case, and also easier the installation, but usually there are a lot of operational issues and reliability issues with these emulators. And we see that the applicability is continuously decreasing because they are also prone to visual inspections, either during PTI or roadside inspections. And finally, we have the modifiers, which can be considered as similar emulators. They can be either mechanical spacers, sensor extensions, mini catalysts, or resistors in this case. We have some public deliverables for all this, so we can have a deeper look on this if it is necessary. We also did a thorough testing activity with 42 commercial tampering devices and services, and additionally 5 home-made, let me say, tampering devices. We did both desk tests, but also in-vehicle tests with light-duty, heavy-duty, and non-road mobile machineries. The key findings of these activities, it's actually an ongoing activity. We are still testing some of these devices, but the key findings are that the ECU flashing is one of the most important issues, as I explained earlier. The quality of the tampering is mixed, both in terms of devices and techniques. And we also categorize the tamperers, so these people that perform these activities. This can start from do-it-yourself solutions, which are mainly the emulators, but also it goes up to, let me call them experts, which are really go deeper inside in the ECU information and operation in order to make mainly the ECU flashing. And finally, we found that there are necessary some years in preparation for these people to have ways of tampering when a new vehicle is in the market. If we go on objective number 2, and this is about our solution, we start from the base level, which is the conventional OBD, and we expand on 2 additional levels. The first level takes some early actions against tampering activity, and in the second level we have the cloud reporting. I will explain later a little bit more things about these 2 levels. So for level number 1, we developed some dedicated tampering detection functions, for example for ACR tampering here, and we also provided advanced diagnostics such as the anomaly detection method, to cover also future attempts, future emulators, and future services. In terms of security, of in-vehicle security for the digital communication in the vehicle, we developed protocols for cryptographic key distribution, and we used some well-known methods. And we also developed some specially tailored protocols for digital sensors, and an example here is the Secure CAN based on the AutoSARS EcoC specification, which is one of our key solutions for communication of sensors in the vehicle. And finally, we developed secure boot and secure firmware updates for the XEUs, mainly for the ECU, the electronic control unit of the vehicle, but any other control unit in the vehicle. And also firewall and intrusion detection systems to filter the malicious tampering attacks and block these attacks and these attempts. For the level 2, as I said, we are focusing on tampering reporting, and by reporting here we say that we have the input from data from many vehicles, fleet data, and as output of this activity we have some certificates which can be easily verifiable using, for example, the SSI technology. And as you can understand, this involves several parties, starting of course from the vehicle, but we see necessarily also the PTI authorities, the vehicle licensing authorities, and the so-called emission certificate authority, which this authority will provide the authority and the final access to the vehicle data. The third objective, and what we also did and we are currently doing, is a demonstration of this, of the success of our solutions and the countermeasures. So we have installed our tampering system in a demonstrator vehicle provided by Ford Otosan, one of the partners of our consortium, but also we did several standalone lab demonstrators, which helped us a lot to understand some specific points in these solutions. We evaluated these solutions and we're currently evaluating them both internally with some independent verification and validation systems, but also externally using hacking events. We have already done, the first hackathon last year, and today and tomorrow we are running our second hackathon with some white hackers, so some ethical hackers, to evaluate our solutions. In terms of the final objective, which is the guidelines and the recommendation for future legislation, the plan is here to have some text which will be uniform and technology neutral. We have put a lot of attention here in order to make sure that we have solutions that can be applicable industry-wide and with no specific needs of patents and so on for the majority of them. And we are also planning to provide specific implementation timelines for these activities, and I will explain later also a few things about the connection of our activities with the Euro 7. In terms of testing protocol, we see it equally important to have a protocol which can be either a physical test or a functional requirement, or even some administrative requirements here, in order to test that the solutions not we, but anyone is developing for anti-tampering are valid and effective. And I go now on the expected impact of DIAS. This is an overview. As you can imagine, the overall target is to contribute to the Green Deal towards a toxic-free environment, but we are specifically trying to address and have an impact on both economy and also a commercial impact. Of course, environmental, health and societal impact, and here we are also performing a sensitivity analysis, and we assessing the effect, so an impact assessment of both tampering but also the anti-tampering solutions that we are developing. And finally, in terms of regulation, to support the authorities with advanced tools to monitor, at the end, vehicle fleets. And I would like to conclude with this final slide, which tries to connect DIAS with other relative activities in the area. We have seen from the proposals from the technical committee for Euro 7 that the future emission compliance framework maybe contain and combine information and data from various sources, starting, of course, from the vehicle, but also we have PTI, remote sensing and roadside inspection, and type approval, ISE market surveillance data. All these can be combined and gathered in a cloud, and we see that it's really important in all this chain to have reliable data from the vehicle. So if these data are tampered, we cannot simply follow this chain and have a reliable framework for future emissions. So I would like to close with this overall expectation that we see that the solutions and these guidelines we are going to provide should be an important part of Euro 7 legislation. Thank you very much. I would be glad to receive, of course, questions later. You can visit our websites and Twitter account for more information. Thank you very much.
Thank you very much for another very useful presentation that highlights how widespread the problem of tampering is and what we need to do about. And we pass now to the fourth project, There's project NEMO, which is an acronym that has been used to previous projects, but this is a project related to emissions. It's about noise and emissions monitoring and radical mitigation measures. So I give the floor to Cecilia Matea.
Yes.
Yes.
Hello, good afternoon, everyone. I'm Cecilia. I work at Transport and Environment. For those of you that don't know us, TNE is a Brussels-based green campaign group focusing on transport decarbonization. So we are one of the coordinators of a work package in the NEMO project, which is around noise and emission monitoring systems. So the NEMO project comprises of 18 partners in total, including 2 universities, and as you can see from the map, is quite widely spread out across Europe. The project kicked off in May 2020, and we are now close, going on to the final part, which is also the more practical part of the project, as I will explain, closing off in a year's time. So the project really develops across 3 technology pillars. The first one, and it actually ties in quite nicely with the projects covered so far. So the first one is around developing an autonomous remote sensing technology, which wants to be both accurate and cost effective. So the aim really is to identify those high emitting vehicles in near real time. And that includes not only cars, but also trucks, motorcycles, and rail systems, as I will go through in the presentation. The second technology pillar is around noise measuring technology. So that's, I guess, in addition to the projects covered before. So it also looks at noise from road traffic use, so looking at engine speed and load, but also rail traffic, determining each single wagon on trains. And then the third part also looks at even lowering pollutants present already in the air via negative emission solutions, namely through infrastructure applications such as asphalt materials and multifunctional barriers. The remote sensing technology is being developed by Opus in Spain, the noise measuring one by Müller, which is a Dutch and German company, and the new materials and negative emission solutions from the University of Cantabria in Spain and Gustave Eiffel in France. Then, of course, all of this data needs to come together in an IT system. So that's also one of the objectives of the project. So to develop this IT and software infrastructure based on remote sensing data, both at combining ultimately both noise and exhaust emissions, so that this data can be read, combined, and complemented across both different types of pollutants. The project then is we're currently setting up a communication with the driver, but also with the road or rail authority from the remote sensing system. What does this mean? For the driver, for example, we're setting up some screen boards, testing them out in the different locations that warn the driver, for example, that if they've gone over the noise limit, so maybe it displays a message of have your car checked, or you're driving too fast. So it also trying to detect what is causing the issue with the noise, or it warns the driver also, hey, there is an issue with your emissions, have your car checked. This information in parallel also goes to the road authority system, for instance, which obviously needs to follow through to verify if it's also a tampering issue, for example. These technologies of the NEMO project are being deployed across 4 key locations. For road transport, that is Madrid and Florence. And for rail is more focused on the south of the Netherlands and the port of Valencia. So this is the technology that Opus is developing, the remote sensing one. So really the key here, as I said earlier, is to detect the real driving emissions. The technology is a laser-based one to go beyond state-of-the-art, and really the focus of the project is to develop this technology in Europe and to make it more affordable for cities and for users in general. The system will have capabilities for both portable and fixed monitoring, including infrastructure integration integration for intensive operation. So the milestones of the project so far regarding this technology have been successful deployment of the alpha prototype, sensitive and precise measurements of different types of pollutants, which you can see here in the slide, and then also we're getting it patented. As the next steps, as the more practical side of the project comes in, so integrating it with other sensors of the project and with the IT platform. We're doing a performance validation at the GRC, which is also one of the partners of the project in Ispra. And then the first pilot project will roll out in Florence this summer, hopefully. With regards to the noise remote sensing device, again, the idea is to develop this a fully automated measurement station that can detect both vehicles and trains. On the trains, just a word on this. So I mentioned earlier that it identifies single wagons. What does it mean? It's basically able to identify which wagon of a train is causing the noise problem. And we've so far done 2 vehicle demonstrations in the Netherlands and in Germany. And the results were that it was able to measure and classify roughly 10,000 vehicles a day. It was particularly successful in Rotterdam with great interest from the city council, and I'll come back to this in my final slide. Then moving on to the new materials and negative emission solutions. So they are 2. The first one being the asphalt pavement. So really this asphalt has both mechanical properties, surface properties, so enabling further resistance, as well as air cleaning properties. And what they're testing also, it's not just exhaust pollutants, but also microplastics released from brakes and from tires. And then the multifunctional barrier is an external noise barrier with a biofilter, and it'll also have an integrated green wall system. And we're currently scoping out partners or interested cafes or restaurants, I guess, in Madrid to test this out. And this, as I mentioned earlier, the University of Cantabria is leading on this part. So what the impact of the what the project wants to achieve basically overall, so we're currently working on a white paper that outlines what the policy options are for the project to achieve a 30% reduction of exhaust emissions and a 20% for noise in targeted zones. It wants to develop, as I also mentioned earlier, this EU-based cost-competitive remote sensing technologies via Opus and Mueller. On the policymaking side, I will tie in from what the earlier project said, really, around real driving emissions. So what role can they play in future EU and cars and truck standards? So notably Euro 7, but also the role they can play in periodical technical inspections, as well as efforts with tampering. And most interesting, also, the project has a really has a big focus on cities and the role that remote sensing devices can play in better implementing low emission zones, for example, in cities, or zero ultra low emission zones. So is, for example, a PHEV driver using the engine mode in a low emission zone. So the project within that context has launched a city exchange network where cities can really raise concerns and share best practices with these type of technologies so far. And just to highlight that one of the key concerns raised is around data from users. So who owns it? Is it? We're solving this mainly via the road transport authorities at national level. But it's just a wider concern that cities have raised over and over, and perhaps it's worth more looking into. I didn't prepare a contact me slide, but you can reach out after the presentation. Thank you.
Thank you very much for another remarkable presentation covering the impact of both emissions and noise, and tampering, of course, which seems like a widespread problem. I will pass the floor now to Simon Edwards from Ricardo, who is going to coordinate the technical discussion, and the floor is yours for any questions. Simon?
Thank you, Georgios. Good afternoon from my side, ladies and gentlemen. I think you know how it goes now, but we've had 4 excellent presentations over a broad range of aspects, road transport and health related, and the relevant emissions. So from my side, first of all, again, thanks to all the speakers for your presentations. But we now have about half an hour for question and answers. If I do a quick calculation around the room, that gives each of you the opportunity to ask about 2 questions, one every 30 seconds if you want. So please do not feel shy. I know you are much more expert than I am in this topic. So please, has anybody got any burning questions that they would like to raise immediately? If you do have, please, in the first instance, state your name and affiliation. I know the room is small and we may know many people, but Zizis, if you could do me that pleasure the first time as well. Thank you very much.
Thank you, and I hope I break the ice. This is Amaras from Aristotle University. I have one question for Topi and one for Cecilia, if I may. For Topi, quite impressive, actually. Thank you. However, what I was unable to catch exactly is how do you relate emissions from specific type of engines or technologies with emissions or air quality data that or filters from air quality measurements that you have collected. You said that you will be giving specific guidance about the development of technology. So this point is not very clear for me. That's the question for Topi, if you can give us those. And maybe I can ask the question to Cecilia. Cecilia, can you tell us what is the technology behind the noise sensor and the PM sensor, if you can? Thank you.
Okay, thank you, Professor Samaras. In our 2 project, we make experiments with different engines using different fuels and different exhaust after treatment systems. And during those experiments, we measure by aerosol instrumentations both the size distributions of primary particles, fresh exhaust particles, and aged exhaust particles, and the composition of those different phases of exhaust. So from experiments, we can get very comprehensive data on the characteristics of the particles. Then we are using, for example, a CPC battery, where we can count particles larger than 1 nanometer, larger than 3 nanometers, larger than 10 nanometers, and larger than 23 nanometers. And that kind of data may produce interesting information also regarding the existing and possibly upcoming regulations related to the road traffic. Then that kind of data for individual emission sources, individual technologies and fuels can be compared in our project to the particle size distributions in real environments, in real road environments. And it can be compared based on particle size distributions, based on those particle number concentrations, and based on composition of particles in real traffic environments. So we aim to understand how much those new and old technologies tested in laboratory conditions may affect the characteristics of particles in real environments. And those real environments means in our project city of Helsinki, then Düsseldorf and Prague. And we use our mobile lab with, for example, aerosol mass spectrometer to characterize the composition of particles in traffic and then concentrations of those particles. And we always do our measurements in that kind of a real environment so that we measure also NOx and CO2. And using CO2 we can calculate real emission factors for traffic. And then again, we can compare real emission factors, for example, sulfates for real traffic, and then that kind of emission factor for individual technology tested in the laboratory. And then in our two projects, we combine our laboratory measurements with sampling of particles. And those particle samples, meaning particles on filters, they are used in cell exposure studies. And then we can detect how much those particles change, for example, genotoxicity of. We can detect how genotoxic those particles are from different individual technologies. And then, in addition to that, we have used so-called air-liquid interface devices in all of our experiments in laboratory. So laboratory experiments can tell us probably how much different technologies affect the cell toxicity. Then if we know, and when we know the characteristics of particles in those exhaust samples, then we can compare those characteristics with real-world characteristics of particles. And that kind of chain can really open the understanding how individual technologies in vehicles affect the effects of particles on human lung cells, for example. But the amount of data is so huge in our project, and we have 1 year left. So it means that the final results may be slightly different than I described here, but there is promising results. For example, in one experiment we generated soot particles and then mimicked the formation of so-called fresh exhaust and then aged exhaust, and tested all of those phases with different kinds of human cells, and we really saw differences in those experiments. So that there are effects of particle characteristics on cell functions.
Thank you, Topi. Although this triggers maybe another 5 questions, but still we can continue outside, I think. Thank you very much.
I was thinking exactly that, a very comprehensive answer which must generate more questions, but we've possibly got time later on. But in the meantime, Cecilia.
I should have said a disclaimer that I'm a policy person and not a technology person, but I'll try to answer your question. So on the noise emission side, what I know is that the system is a microphone array system, and that basically is based on the psychoacoustic disturbance of noise, which is a bit tricky because there's not a homogeneous policy around it. But I'm happy to put you in touch with the right people in the consortium that lead this to better explain it. And then the technology on remote sensing, so for pollutants that Opus is developing, is based on a spectroscopic absorbance via infrared and UV light, and it basically can mirror and detect the different pollutants that are present in the air, so CO2, particulate matters, and so on.
Including particulate?
Yes, yes. Yeah, so they've also, Opus was previously funded also by another EU project, LIFE grant agreement project in Madrid specifically, and there it was quite interesting because they deployed it in the Madrid low emission zone, so the type of vehicles, well, which is it's a restricted vehicle zone rather than low emission, but there they were able to really create a very nice data set of the type of vehicles that circulate in Madrid and how many go beyond the Euro 6, for example, emission limits. Yeah, for both, yeah. Yeah, they look at both.
Excellent, thank you very much. One hand raised here. Maurizio, please. And Xavier, whilst I've just got the microphone, do you think we can have a neutral background rather than just continuously presenting the last presentation? But Maurizio, please.
Yeah, thanks. Thanks everybody for the interesting presentations. And actually, I have several questions. So I will ask a few, and then if there's nobody no more, I might ask the other one. One is about the results from Tube. I had, I think, Professor Kanninen in the Green Week in the session, and she presented very interesting results on brain effects. For instance, I remember she said something like that with exposure there were basically Alzheimer-like result impacts on children. So I was expecting in 9 months after to see more. Can you say something about the progress in that area, which I think is very frightening on one side, but very interesting, let's say, outcome of the project. Then another one, I think, which is at the top, is in Modales, you mentioned, I think you said OBD optimization. And actually, I put OBD in because there were known cases of tampering of defeat devices there. And I wanted the projects to look into what was the situation now, because of course, if the driver is not warned that there is an issue, he will not repair it. So the high emitters might be either people ignoring the signal, or people not having the signal even if the problem is there. And the topic was written under that assumption. So I don't know if this optimization is that, or is something else. And in case, if and when you are doing this kind of checks, which I think were done planting errors and seeing whether the system was detecting them. And a brief one on NEMO. On the noise, is the system identifying basically tempered cars and motorbikes? And is there a follow-up? I mean, is that experiment done like as has been done for tampering of trucks? That basically there is the police there checking then physically and in case prosecuting the offenders?
Thank you, Maurizio. If it's okay with the speakers, can we take that in order? Possibly, please. Topi, if you can just answer first of all.
Okay. The question was that can we say something more about the Alzheimer disease effects? Or
yeah, dementia and so on, because I think there were interesting things there.
Yeah, so the main motivation for the project was to understand better the mechanisms mechanisms behind the effects of particles of particulate pollutants on Alzheimer's disease. And we have done this research from different viewpoints. I'm leading work package 1, which is focusing on emissions and air quality measurements. And in that respect, we can now analyze for example, the fraction of particles that can deposit on upper airways of respiratory tract. And that is important because those particles depositing on head airways, they are probably very small, and then new technologies may produce more those smallest particles. So there can be even some kind of trade-off, but we don't know quantitatively the that phenomena very well. But we can and we will analyze the amount of particles that can be deposited to the upper part of head airways. And then we think in the project that there can be two main mechanisms how those particulate pollutants can affect human brain. and those are direct effects, so that they go to brain via so-called olfactory nerve, and because we have now data from ambient air down to 1 nanometer, we can calculate or evaluate the role of those smallest particles in respect of the deposition of those particles in the areas where particles can go to olfactory nerve. And then the other work packages may continue from that part, and I don't know many details just now, but I can ask it if needed. Then the other mechanism is that those particles go to lungs, and then they can go to blood circulation system, and then they probably can affect some inflammation reactions in human body, and they can affect the function of human brain. And this is also important to study, and we are doing something for that question in the project. But
yeah, thank you. Just to precise one thing, then, because at the time she was not able to tell me. So the olfactory, you are seeing basically that is only the smallest fraction of the smallest fraction that can pass through there. Is there a kind of limit, let's say, below which it's through the nose, and instead other bigger particles can arrive through the blood or something like that?
Yeah. Ultrafine particles are very small particles, and those particles go to human lungs very efficiently. But the smallest particles of ultrafine particles deposit efficiently to the nose part of respiratory tract. So because of the diffusion motion of those particles, they go to surfaces of head airways very efficiently. And I mean particles smaller than 10 nanometers, for example. So, yeah, they are there.
Thank you. Let's move on down the line then. Andy.
Okay. I'm afraid there's not a lot I can say for your question right now, partly because it's work that's ongoing, and secondly because it's not a task that I'm involved in directly. But it's not so much about tampering of OBDs. It's what we're doing is collecting annual inspection data in a few European countries. We've got Greece, Turkey, Spain, I think Finland is coming too, and so there's analysis ongoing of the reasons why vehicles have failed their annual inspection, the main points of concern, and then parallel to that, some of our partners are going to be looking at the ability of OBD to detect these main failure points. So yeah, it's not so much on tampering of the OBDs. All of this will be in a deliverable that is, we're now looking at June, July for submission. So this will be public, so we can let you know when that comes out. I can give you a bit more information later this week by email. I've got the contents and so on, the deliverable on my computer, but not in my head at the moment. But
okay, basically, you probably you will get the same data simply because the guy who goes to the inspection don't have a mill on, because otherwise they would know. And if you find that there is a certain quantity of, it means that the OBD is not detecting them. So it's a it's deductive approach instead of a active approach, let's say.
Yeah, yes. Okay. It's also one of the issues with inspection is if people do have something illegal or tampering or whatever, they'll probably try and sort it before they send the car for inspection.
Yeah, no, but this is not for the tampering. This is really for the OBD being working only on the test cycle, as it was happening in some cases.
Okay, thank you. And finally, with this set of questions, we need questions for Dimitrios, by the way, next time. Otherwise, I'll ask Dimitrios a question myself to give the others a bit of a rest. But Cecilia.
Yeah, thank you so much for that interesting question, Maurizio. So, to be honest, no, there's no planning on following up with the tampering for now, other than the warning system for the driver. I think it's I've taken note of it, and I will raise it within the project if perhaps it can be followed up even as a policy recommendation as part of the project.
Your cities, so
Yeah,
expecting that
yeah.
Trying to get some results.
Yeah, for them it's more interesting the emission side than the noise side, to be honest, especially because the rail side, it's more cargo rail, so outside of the city and so on. But yeah, I will thank you.
Thank you, thank you. So let's ask directly, Maurizio, do you have a question for Dimitrios?
I have one, but since it was, if there's nothing else, then
I don't see any other hands raised, so let's. Then Dimitrios is going to get 2 now for the next few minutes. Apologies about that, but we've got to keep it equal. Okay.
You ask it, you get it.
Well, the floor first, and then.
No, Georgios, please.
Okay. So you mentioned in the presentation that you estimate around 10% of the vehicles in the EU are more or less tampered. So this is quite a huge figure, and shows that there must be a whole industry, let's say, behind it. That tampers probably in some countries it must be even higher, and some others a bit less. So my question is that is it possible, like one of the proposals, to have let's say done on a manufacturing level, that once somebody tries to tamper his car, the vehicle will become like a brick, I would say, on the mobile phone. That if you try to tamper your mobile phone and bypass its security things, it can become a brick. This is a huge risk, and this puts you off from, of course, trying to tamper with a mobile phone. So I was thinking, whether one of the possible recommendation will be on a manufacturer level, say that the anti-tampering thing is that, okay, in case tampering is detected, an attempt of tampering is detected, the car gets immobilized there, and then you have to pay 5,000 euros to the manufacturer to bring it back to life,
Yes, thanks a lot for this question. It's really interesting. Let me clarify that from overall, we are trying to provide guidelines for various end users, and one of these is, of course, the OEMs and the manufacturers. We have the level of detection but also prevention, and our main focus is on prevention, so to make it really hard. But if it is not possible to make tampering really hard, detection and maybe some follow-up fines or whatever, any other solution from the point of manufacturer could be necessary. So we are planning to make it a little bit more specific and provide some guidelines for the next levels after detection of tampering. I'm not sure whether this should be a fine, as I said, or, as you said, to stop the vehicle. For example, already for urea there is a similar approach. We are planning to propose to extend this also to other exhaust after treatments, but honestly, we really want to focus on prevention and not so much on detection and the measures after that.
If nobody else raised anything, yeah, one from your presentation, I had I noticed this small note about EGR being less of a problem in Euro 6. I might think about a couple of reasons, but then maybe you can tell me which is the right one. Well, one could be, of course, that due to the presence of SCR is used less, but on the other hand is used normally when you have more pollution at cold start and so on. So I wouldn't expect that to change a lot, but maybe. And the other could be that now the OBD detects the problem and therefore you have more, let's say, repair on that. I don't know. What is the reason that you thought?
Yeah, thanks for this question. For EGR, we had an issue in Euro 5, and this was mainly the failures of EGR. So this was the main motivation back then, to avoid replacing malfunctioning EGR valves. So for Euro 6, the failures are significantly lower. First of all, this is an important reason, but also manufacturers paid more attention on preventing any tampering of EGR. This is correct again. But there is also another point here for EGR. As you also said, it's not in Euro 6 the main anti-tampering. ACR is there to make the job that EGR did in Euro 5. And for these reasons, they really don't pay a lot of attention on EGR. But on the other side, we have found that it's really common to have a package of everything. For example, for heavy-duty vehicles, if someone goes for ECU tampering, the solution is remove everything, DPF, SCR, EGR, whatever is there. So the comment, I think it's valid mainly for passenger cars, and for heavy duties, I would say that it's more or less a package to remove everything, so it's maybe still the problem.
And then the damage is huge, because for if you take away the particle filters, you said that it's like 10 or whatever vehicles. If you take it's thousands of vehicles.
Yes, exactly.
Yeah, another question is that was again, it's a bit more general because we have experts on the real thing, but I think you had measurements on that. WHO, for the first time, has given guidelines, which I really cannot, let's say, assess. So I'm asking you about what, in their view, is low and high particle number concentration in the air. We've never had anything like that in terms of particle numbers. Your measurements that you measure in polluted places, in clean places, and so on, how do they stack? Basically, do you agree with their qualification of low and high, or you think they are too optimistic or too pessimistic or whatever?
Who wants to go first? Okay.
So we have made measurements for particle number in ambient air. And those measurement results depend on the cutoff size of CPC very much. So we can measure 50 or 100% higher concentrations by lowering the cutoff size of CPC. So that affects the low value or high value for particle concentration in ambient air. But in principle, I agree with WHO regarding those low concentrations and high concentrations. I think that in polluted environments, the concentration is above 10,000 particles per cubic centimeter, and then in clean cities, it can be lower than 1,000 particles per cubic centimeter. I agree with them.
Yeah, but the high is, is 10,000, or you've seen much more than that?
Yeah. Then one important technical issue is the time resolution used in measurements, especially in traffic environments. In traffic environments, the maximum concentration of particles can be even 1 million particles per cubic centimeter if you are close to car or close to traffic. And it can be very short peak in time series, but the maximum concentration can be even 1 million particles per cubic centimeter. But then, for example, in Helsinki, typical concentrations in road environments for particles larger than 3 nanometers, maybe 30,000 particles per cubic centimeter, and it's going down nowadays. And then in residential areas, those concentrations can be 1,000 or 3,000 particles per cubic centimeter, which is quite close to the WHO recommendation or guidance.
Anybody else on the panel want to comment on the WHO? I guess or suggestions. I'm looking to Dimitrios maybe. It's not a must.
Yeah, to be honest, I don't have a direct answer on this. I mean, especially for tailpipe emissions. Okay, I have an image there, but not really following this activity. Sorry.
Anybody else? Apologies, my microphone has disappeared, and I know Maurizio has got his own. No, keep it there for a moment.
No. I'm not supposed to use it anymore.
That's the way to get the microphone back from Maurizio. Have a defunct microphone. But no, is there anybody else around the room who wants to ask a question? Really? Then please, do go ahead and let me pass the microphone via Xavier back to you. Thank you.
So it's a question for motales. So we are really focusing on the optimization of the reduction of the pollutant in the emissions. But are we also focusing on the reduction of the consumption? Because maybe it's a trigger for the drivers to know, okay, if I drive that way, I will consume less.
Yeah, very. I think this is a question a lot of people have put forward, because in the past, eco-driving projects have focused on reducing fuel consumption, and clearly the driver then has an incentive, because they will be saving money as well as reducing greenhouse effects. This is a little bit different. As you can imagine, well, it's also in our deliverables. Some actions, there will, or many of them, in fact, if you drive more slowly and more carefully and so on, then you are reducing both, and you're saving money in fuel and reducing NOx and PM. But in a few occasions, there's a trade-off where maybe an example would be if you take a motorway route, you are perhaps using more fuel because you're driving at higher speeds. On the other hand, you're probably creating less in the way of brake and tyre emissions because your speed is more constant. And if you go on a secondary road, you may be using less fuel but more NOx and PM. So there is this kind of trade-off. So we can say to people, yes, you can save money through possibly through fuel, but also through, for example, your brakes and your tyres will last longer. And there is a on the tyres, I can't remember the figures, but you can save, maybe extend your tyre life by about 10 to 15% through certain behaviour and driving styles. So there is money to be saved. The difficulty is knowing where the trade-off is. Do you want to save money on your brakes and tyres or your fuel? And it's sometimes one or the other. And it very much also depends on the type of powertrain. So if we're going into the future with more electric cars, for example, then they might be incentivized to take a different route or a different style to somebody with a relatively high emission older diesel car. So it very much depends on the vehicle type as well. This is something our colleagues in VTT have tried with different petrol and diesel cars. So that was in our deliverable 2.2 last year. But it's something that is ongoing, yeah. The big question is incentivizing people to use or to follow certain guidelines. And we all, most of us want to do the right thing for the planet, but then a lot of us, when we're in a hurry, we just do anything. So it's this is still a challenge. So it's kind of changing attitudes as well as part of it, the softer side.
Thank you, Andy. Xavier, sorry, I'm making you do a lot of work. Probably just one last chance for a question. I'll give the question to the chairman, and I guess he can ask the question and then close the session at the same time. Okay. Go ahead.
Thank you, Simon. Thank you. So one last question, actually, it's about, Mauricio touched upon it, it's about NEMO and how do we deploy this sensor system. Let's say I'm a local authority and I'm interested in measuring emissions and noise and put this kit in several junctions of my city. You think what's the chance to be available? Is the timeline is going to, or does it just remain a prototype? There's no plan for, let's say, manufacturing.
I think from the technology provider's perspective, there's definitely will to further deploy and improve the technology across Europe. What they've asked for specifically, I mean, it's a twofold role. So on one side, it's indeed cities and local authorities, but then the other side, I think, and it ties in with the Euro 7 discussion, is what can, you know, the EU central government do basically to further incentivize the adoption of these technologies, and the role also that market surveillance authorities ultimately can play in relation to remote sensing. But from, I mean, obviously I cannot speak from Opus's side, but there is definitely will and capacity to scale up this technology across Europe.
Thank you, and thank you very much for all this interesting presentation and the follow-up discussion we had. Thank you very much for participating in this project, participating in this panel, and thank you for sharing the results and your insights. And thank you for your questions as well. Thank you.
You said that near the port is 3 parties. Those 3 parties are anything like that.